Hi, everyone. Thank you so much for coming to my session today. My talk is going to be about next-gen travel agents, merging AI Agentic and Neo4j for personalized experience. Thank you, Brandley, for introducing me. I'm going to be quite candid about this, and I'm going to share to you my experiences and what's had been working, what's not working, what's the whole story behind all of these. The talk is going to be divided in 4 sessions, like for the introduction, concepts, the experiments, what I'm doing, and then what's some story behind the scene and what's next. Now, a little bit about me. I'm Astrid. My background is I have a master's in digital media, and I've been experimenting in practical AI since 2001. I'm a Neo4j ninja since 10 years, serial entrepreneur, and actually my previous startup is when I started doing a lot with Neo4j. I'm Indonesian, living in Berlin, and this is why I also have a lot of passion in travel, and this is one of my motivation in making this talk, because I'm a traveler and I like to eat spicy stuff, and I also do marathon now. Now, let's go into what I'm actually building here. So it's a next-gen travel agent. I'm instead of making the scope quite big, I am making it a slightly different scope, like it's a Berlin Museum itinerary planner. The goal here is to create a chatbot, creating a personalized museum itinerary for Berlin visitors. Why just museums and just Berlin? It's because museums I'm just thinking, so when I designed this, I think of something that's quite a smaller subset of travel, but it should have a possibility to expand. Museums are somewhat doable because Berlin has 156 museums. It's big enough and small enough at the same time. The data is also publicly available through Wikidata, and it's easy to test. Now I'm going to go through a little bit of the concepts. What I'm going to talk about in this, the whole like Gen AI and stuff. So what is Agentic AI? You probably have heard a lot about this in the whole talk, but I'm going to go through what I was talking about here. So Agentic AI is a AI that autonomously take action towards that objective. What does it mean? Instead of a regular LLM that you have to prompt every single time for it to answer something, with Agentic AI, it can talk to each other. It can tell you, it can tell each other that you need to continue to finish a certain task. In this way, Agentic AI are capable of self-directed learning, proactive task execution, and it adapts to user feedback. So you can tell them, for instance, in this case, make an itinerary, then it would finish when it thinks the itinerary is finished. Or in like a much more fun example is you can have 2 agents that tells joke to each other, and this could never end, or you can tell it to end in 5 iterations. But that's Agentic AI. So Agentic AI has the potential for personalized real-time interaction that mimic human decision-making, adjusting everything as the condition change. Also, what makes it fun is it's not limited to LLM because you can add multiple tools into the agentic. You can add a real-time search. You can add database connection to it. You can have multiple database even. You can have you can connect it to Google Map, or you can connect it to other tools that you make, like to create charts, to do anything basically, theoretically. So why I'm using LangGraph with Agentic AI, because LangGraph structured agentic AI interaction into workflows, and it allowing it to understand multi-step queries and make adjustments. Like through LangGraph, an AI agent can map and track and refine interactions, and we can sort of make have a small control into it. It's not just you have several agents, you can do everything with it, but you can also have like a tiny control, like a routing, an if condition between them, or you can add feedback from users. In a way, like LangGraph enhances the way agentic AI interprets and integrates Neo4j knowledge graph. Yeah, so what's Neo4j role in my application then? I'm using Neo4j for routing because it uses, graph algorithm can help you create routing for certain points with mapping. Or in my case, I simplify it a little bit and create the database for nodes of closely related museums and close distances with each other. I'm also use Neo4j for knowledge graph, like for the structured data on museums, like what's where the location is. You can use it for populating the opening hours themes and what's this all about. And in the future, you can add factor recommendation with Neo4j, so you can have an added layer of control of the knowledge that you want to represent with the museum instead of relying totally on LLMs. Okay, now the experiment. The application layer, the application architecture that I'm doing for this app, from the front end, I'm using Next.js for the UI layer. I'm actually basing this on from the Neo4j tutorial for LLM. And I'm using LangGraph to facilitate the agentic AI workflow, interaction handling, and data processing. And of course, Neo4j for the core knowledge graph and to manage Berlin Museum network and user itinerary routing. And I'm using the data source from Wikidata on this. Okay, so the agents that I'm using, the agents architecture that I am using for my app is a basic multi-agent collaboration. You see, I have the basic basic premise of the premise of a multi-agent collaboration is you have a router. You have agent here. The agent is the museum expert, the itinerary maker, map generator, and nearby places. What's special about this agent is they are doing specifically one thing. So museum expert is specialized in getting the museum info, so you can get more detailed information about exhibitions. Supposedly, they are the expert in telling you what museum you should go to when you have such and such preference. And then you have the itinerary maker that's specialized in making, like it's an agent that's specialized in itineraries that you can tell you how long it take to visit such museum? Do you need time off or a break time between museum, or how many museum you can do in one day? And then these two, museum expert and itinerary maker, actually connected to a search tool, which allows them to get a more current information. Meanwhile, there's two other agents, the map generator. It's specialized in drawing maps. And then a nearby places that specialize in finding nearby museum. And these two, the map generator and the nearby places, are connected to the Neo4j tool. Now the museum, so how they talk to each other is they go through the router. So museum expert will tell the router when it's done doing their job, and do I need to call the tools? That means they haven't, the tool in that case is they get the search tool to look for more information on the museum, or the router can tell that, or they can say that that their job is done, and they tell the router that they have a final answer, and the router stops the work and tell the user they're done. I mean, give the information to the router. So the router give the information to the user because the agents are done. Okay, this is quite a lot, and I'm gonna give you an example. So let's say my prompt is a one-day Berlin Art Museum. This is what happens in the back end. Like you could see the first agent is a museum expert, and the museum recommendation it gives you is the Alta National Gallery, which is an old, it hosts a collection of older artwork, like from neoclassical, romantic, impressionist, the Neue National Gallery, Gemäldegalerie, Hamburger Bahnhof, and the CO Berlin. If you live in Berlin, you know that these five museums are on really quite different location, and it's not really possible for you to go to everything in one day. So that's when the second agent with access to Neo4j comes along and tells you that only two of these museums, the Neue National Gallery and the Gemäldegalerie, are actually close to each other. So if you want to visit more than two, so if you like to visit somewhere closer to each other, then take these two. And the end result is something like this. Then you have a one-day art museum visit. You could start at the Gemäldegalerie and then have a nice lunch break, and then visit the Neue National Gallery with an optional of Hamburger Bahnhof, even though these are actually, the Hamburger Bahnhof is not so close, but I'll tell you why. These two, the Gemäldegalerie and the Neue National Gallery, is actually quite close to each other. It's around 150 meter or 200 meters, so it's like a 10-15 minutes walk. I find this quite very interesting. But I want to tell you what's behind the scenes of this really simply looks like small interaction, because of the non-deterministic behavior of multi-agents. This one takes 24 iteration. And the reason why it cannot find Hamburger Bahnhof location, if you see here, there's no location for Hamburger Bahnhof, even though it's in the database. It's because database listed it as Hamburger Bahnhof or Hamburger Bahnhof National Gallery, the Gegenwart, which is a different wording. And you can't, I mean, of course, you can add another name for it, but as you know, with the non-deterministic behavior, sometimes the query comes with another name and you have to keep adjusting the behavior, the query and the database from it. And also here, the agents actually, like from this 24 iteration, they take their time complementing each other. So at some point, the nearby places go like, well done, the itinerary is well structured and includes the location of the museum. And then the next agent say like, hey, I'm glad you found the itinerary helpful. Should you need any additional information or further adjustments, don't hesitate to ask. So and then the end, map generator said, great collaboration. You know, the itinerary for a one-day art museum in Berlin is comprehensive, including so-and-so. And so basically they just complement each other, which is okay. I guess it's like a human interaction, but if you are relying on tokens and you pay for this, you probably are not going to be so happy about this. Yeah, so to sum it up, like the experimentation challenges of multiple agent, it has more complexity due to a non-deterministic behavior. And then how to split agent and determining which pattern works best for the use cases are quite difficult. I mean, it's a new challenge, right? So we used to go. We need to change our way of thinking of what agents are. It's not really just function because they are seemingly like human. And how to create good prompts for each agent and how they connect with each other is also a challenge because describing what each agent do and what even a tiny difference in how you describe the prompt could create a misunderstanding with other agent. And if you have more than two agents, you have to make sure they still communicate well with each other. And like how the minor tampering of the prompt could affect the result. I mean, we were trying to get a valid JSON format in the end. And this is basically how I felt. Like I kept telling the agents to do a valid JSON format, but somehow it always find a way to veer a little bit. So this is another challenge of the non-deterministic behavior of this multi-agent of the LLM. Yeah, again, the non-deterministic result makes it really difficult to debug, especially with multiple agent. I think I saw, yes, I saw someone asking how to evaluate this. This is really a challenge with multiple agent. If you find doing one agent is already difficult, like with multiple agent, you need to evaluate in every single step, I guess. And yeah, especially when you need a precise result in with some application. What I need with having a JSON in the end. This is more difficult to process because every agent seem to reinterpret things, and this is a challenge. Yes. Oops. The technical challenge for doing this was the evolving AI landscape. There's, as we all know, new best practices seem to change every month, every week, even when I started doing this doing this application in March, April, I think the best practices for agentic structure is different. And then just a week ago, there's a new ChatGPT search that probably don't really need to have an LLM agent that connects to a search tool. It also has a limited example in JavaScript, TypeScript, because most of tutorial example is in Python. And if you want to do a web-first tech stack in TypeScript, you basically need to do things your own. The data resources, of course, for a startup, that has no access to a big company data, it's always a challenge. So what's next? For doing this app, you can do experiments with other agentic architecture. I think someone asked when to choose to work. Nuha asked when to choose to work with supervisor agent and when to use the router. You always choose to work with a supervisor. So it's supervisor agent would be another architecture. This one with a supervisor agent is like another agent, because the supervisor, I mean, imagine like supervisor agent is another agent. It's a supervisor. It's an agent that tells other agent what to do. And the router is a simple if else. So if the agent asks for a tool, then the router says call tool. If the agent says I'm done with, I think I have a final answer, then the router sends the information to the user. Which one should you use? It really depends on what kind of application you're trying to do. And I don't have an answer, a definite answer for that, because it's always like still a trial and error for me as well. Because even if I want, I mean, I'm guessing with the supervisor agent, you would have a more complex situation, because you can't control the behavior of the supervisor, even because you don't know which agent the supervisor would want to call with a certain interaction. And with the router, you have a little bit of control. So it depends on, do you want more control? Do you want to trust another agent to do everything, to do all the interaction of the agents? Yeah. The next step that needs to be done for this application, of course, a real-time feedback loop, because right now it's not, I mean, it's still, so user asks one question and the agent cannot ask a question back. This is the next improvement. And then expand the data, because if we don't want to do just Berlin museums, you want to expand it to other attractions, museums, to to restaurants, to monuments, surrounding cities. Enhance the personalization. If you want, if you can know more about the users, and also language and cultural adaptation. Right now it's only in English, but I'm hoping to get more of this in the next step. So yes, for me, the end nodes for this is the next, like multi-agent. It's quite challenging for startup to keep up in this AI world and not get eaten by big companies. As I see ChatGPT is trying to do travel and I'm doing travel, there's always certain fear there, but we keep going, right? It's also challenging for developers to invest in new technology, which one to learn and when. Should I wait? Should I start now? Nobody knows. But as a good developer, I think we always should learn, should keep learning to improve ourselves. Even if this might not work in next year, but you would learn something that would help you get into the next stepping stone. And this is what I learned most from this is the prompt with the prompts. It's the misunderstanding, miscommunication happens even with agents. It's almost like talking to a human. So you need to understand the nuances really for each interaction you tell the agent. And I figured this would be quite difficult also you if you're a non-native speaker and you don't really understand the nuances in languages and you want to prompt in the language don't like you don't understand when your application is breaking down. It used to be easy to debug things because you just put like the application tells you, okay, your loop isn't correctly going. But with non-deterministic and with prompting, you never know. I mean, one day, one iteration it works, the next one it does not, and the next one it works again. So it's very interesting thing to try. If you want to learn more about this, I totally recommend the Neo4j Graph Academy. Deep learning AI, of course. That's where you can learn a lot about multi-agents and agentic architecture. Also, with LangGraph has really great resources on that. Yeah. Thank you so much. I think someone asked to. Okay, I'm going to. For the, okay, you can send me an email for the GitHub repo. I still need to work on, it's not public at the moment. I will send you a link when it does, and just send me an email or connect with me on X, LinkedIn, or Instagram. Okay, I'm going to try to answer some question with the tiny time that we have. Okay. Yeah, the experiment available on GitHub. It will be just not at the moment, but feel free to write me a message and I will let you know when it's on GitHub. And for the current agent frameworks, I recommend LangGraph actually because it's they have pretty good documentation. It's quite complex, but I think it's much more complex than we think it would be. From what everyone is telling you to, but they have good documentation, so I recommend LangGraph. Okay, thank you so much. I think that is the end of my talk then.